This episode is the third in a three-part series on, well, I think you can see for yourself what we're doing this episode. Let's get to it. Hey guys, welcome to today's episode, and I am particularly excited for the episode today. And I know I say that a lot, but this episode is different. And if you've been following along with this series, I think you're going to understand why by the end of this episode. So with the last two episodes, and really it's been the last three, because 3 episodes ago, that was when we got our gameplay abilities integrated with our AI, we've been focused on how do we make an AI character attack. And this episode is the final piece of the preliminary setup. And I say preliminary because right now we only have a few gameplay abilities. We have 2 attacks, a flamethrower and a fireball. But I think by the end of this episode, you're going to have a solid sense of how AI combat could work, and we're going to be well on our way to making a viable game. And the reason this episode is so long is because we're really doing 2 big things this episode. We're setting up the AI to be able to effectively pick up abilities. And you'll see why this is a little bit more complicated than you might think. But the second part of this episode, so that's the fun part. So that's the AI optimally positioning itself in order to attack. And just a few new concepts today. I think the only thing here that's really net new is the EQS donut. And you'll see where this makes sense. But really this entire series, everything we've been doing up until this point, it's to get us to this episode. It's heavy blueprint logic, but we're going all out. So let's get to it. All right, so we're going to start this third and final episode in our adversary AI controller and also our adversary AI character. So open up these 2 actors here. And what we're going to do to start for our AI character right here, we're just going to check to see, okay, if we let him loose in the wild, does he acquire abilities and how does he go about doing that? So I'm going to start over in our adversary AI controller, and we're simply going to set our default mode here to acquisition. Compile and save this, and then over to our adversary AI character. So if we scroll down to our character movement component, we could search for acceleration and set this back to 1500. And then if we go into our jump and movement check function, we got to rehook up all these nodes that we deliberately disconnected. And 4. So compile and save this. And next, what we're going to do is take a whole ton of gameplay abilities and just duplicate. So Control D. You know, it's sad I've been saying Control-C copy, Control-V paste for how many episodes? 65 episodes. And it's just Control-D to duplicate. So apologies, guys. I'm a slow learner, but I learn eventually. And we're just going to duplicate Control-D. And all we're going to do here is we're going to place a ton of these abilities up the hill. So we want these to go pretty much all the way up to the top. You could duplicate various ones. Really doesn't matter at this stage. All right, so we got about 5 additional abilities placed everywhere from halfway up the hill to all the way up the hill. And then we can just get close to our character here and simulate. And what you should see is he picks up the first 3 abilities and then, well, he runs right past the next ability and it looks like he's heading, for the last one that I placed? So the first issue here is that he's not taking the most efficient path to gameplay abilities. So how do we fix that? And the way I thought about handling this is potentially doing something very elaborate where it's building basically a route to the gameplay abilities. And then I thought to myself, it shouldn't be that difficult, right? Because testing out AI perception, when our AI perception perceives abilities, it's perceiving all of them at once. Like everything in line of sight, it's actually perceiving. And so I thought to myself, could we just build an array of all the perceived gameplay ability actors? And then every time we pick up a gameplay ability actor, the AI could assess, okay, what's the next closest ability for me to pick up? And that solution ended up working really well. And the way I came about this solution, really a simple solution, is I did a print string right from here. And I said print string, and we're just going to print the name of the actor that's perceived. So just like this, compile and save from on-target perception updated in our adversary AI controller. And then when I play, you'll see that he sees the 3 gameplay abilities, and then when he turns, he sees 3 more. So he sees all the gameplay abilities at once, and that's where we're going to build our array. And by the way, this is also how we're going to handle in the future if we do like a free-for-all mode. So if there's multiple targets, like multiple enemies, the AI will be able to track every single one. So our first step, if we go back into our adversary AI controller, what we're going to do is we're going to duplicate our current target variable here, duplicate, and we're going to call this potential acquisitions. And it's an actor variable. We're going to right click, turn that into an actor array. And the other thing I'm going to do here is I'm just going to clean out our print string, connect this true up here, and we're going to take our active acquisition scene function. We're going to duplicate that and we're going to make some modifications to it. We're actually going to end up retiring this function, but you'll see why. So under AI perception, active acquisition scene, right click and duplicate, and we're going to title this acquisition assessment. And this is not going to be a pure function because we're going to be updating this array, this potential acquisitions array. So I'm going to move this over and then right click on actor over here. We're going to promote this to a local variable. And I'm going to title this down here. If I rename, it's the local actor to assess. And we'll connect it up here. So we're going to keep all this stuff pretty much the same. We're just going to take our local actor to assess and plug it into these two spots. But instead of just hooking this up to the return node, so what I'm going to do is I'm going to move this out. We're going to do a branch from this. So we're going to branch, connect this up here, because we first want to assess, okay, does the actor that we're perceiving, does it meet the minimum requirements to be added to this array of potential acquisitions? Like, first of all, is it an acquisition? Make sure it's not inert. Can we actually get to it? And if all those things are met, then we're going to add it to our array of potential acquisitions. So all of this, that's the first check. That's this branch here. But then we have to do a second check, which is maybe the potential acquisition is already part of the array. So I'm going to compare our local actor to assess. I'm going to compare that to potential acquisitions. And I'm going to say, okay, does this array already contain the local actor to assess? And then from here, I'll drag this out some more, and then we're going to branch again. We're going to connect up the true here. I'm going to move this down a little bit, because if this is false, meaning this doesn't contain the local actor to assess, then we're going to add it to our array. But we're actually going to add unique. And add unique, all it's doing is it's making sure it's not already in the array. I guess this is a little duplicative, but we're going to do it anyway. And then for our return node, I'm actually going to disconnect this, and we are going to rename our return value. And this is going to be called can acquire ? And then in this case, yes, we can acquire. And I'm going to connect up this here and true right here. And these I'll move in, because even if it already contains it in the array, it's still passing this check, which means it can be acquired. But let's say our character senses it again, like it's picked up by some other character. And then when it's sensed again, then this is false, because then it would be labeled inert. So in that case, we want to come down here and we want to branch. And we also want to check this same thing, like is it already part of the potential acquisitions? Because if we can no longer acquire it, then we want to remove it from the array. So if this is true, we're going to get our potential acquisitions local actor to assess, and then what we'll do is we'll say remove item. Connect this up here from the true. And then we could take our return node, copy, paste, and this one is going to be, nope, we can't acquire. Move these in, false pin also there, and we'll put in a couple of reroutes. And then we'll compile and save this, and we'll go back to our event graph. And then what I'll do is I'm going to zoom out. We're going to make a little bit more space under here. We're going to delete out our active acquisition scene, because instead we're going to take our branch and all this stuff, move it out. And then this pin here, I'm going to disconnect, and I'm going to drag in our acquisition assessment function. And I forgot to change it to not be a pure function. So we'll uncheck that. So it's actually executing, and then we'll connect up here, connect up here. Can acquire will be connected right up there. And we got to make sure to connect up our actor and stimulus. So that's going to be here and stimulus to here. And add a couple of reroutes in. We're getting close to the point where we're going to collapse all this stuff down to a single function, but hold tight. So if it looks like this, then you're good to go. And the last thing we're going to do is this active acquisition scene. We are going to delete that function, compile and save. We don't need it anymore. We're sticking with this. And the next thing we need is we need a function that's going to allow us to get our closest ability in the array. Basically, it's going to run through our array and it's going to say, okay, which of these is the closest ability? And that's going to update our target. Basically, on perception updated, then we're updating the potential acquisitions, and then we need to assess which acquisition to acquire. So we're going to create our new function here, plus sign. We're going to call it get closest acquisition. And this is going to be a pure function. We can check that off. We're going to take our potential acquisitions, this array, and we're going to do a for each loop. Connect this up. And so now we need two local variables. So the first one is going to be titled local shortest distance. And this one, not an actor, it's going to be a float and not an array. So right click on that. And the second local variable is going to be, if I scroll down, it's going to be the local closest acquisition. And this one is going to be an actor. So I could search for actor. And this one, object reference. So compile and save once we put in these local variables. And the local shortest distance, so by default, I'm going to set this to something really high, like 100,000, something that's way further than what our actual closest actor will be. All right, so then for all potential acquisitions, what we're going to do is we're going to get the actor location, and then we're going to compare that location to the location of our possessed pawn. So we can get our possessed pawn, and we could say get actor location. And from these two things, we're going to get the distance vector between the two, connect these up. And then we're going to check to see, okay, this potential acquisition, however many are in the array, let's compare our local shortest distance. So get our local shortest distance and see if this is greater than the distance down here. Because if this is greater than this, then this new one that we're running through with this array, this is going to be our closest acquisition. So we'll connect this up via a branch, connect up the loop body here. And then if this is true, we'll get our array element here and we will set our local closest acquisition and connect this up to the true. Only if the local shortest distance is greater than the distance between what's currently being assessed. So I'm going to put in one reroute and then a second reroute, connect it up like this. And then the local shortest distance, I will set that as well because that's what's going to be compared with the next element in the array. And then this gets connected up here because that's what we're setting to our new local shortest distance. But only if this is true. If it's false, it's just going to go right on to the next thing in the array until it's complete. And then when it's complete, it's going to get our local closest acquisition, whatever that is. And this is where we need a return node. So I can search for add return node and we are going to create an output on this return node, and it's going to be the closest acquisition. Boolean, switch this over to actor. Down here, actor object reference. Connect this up here. Last but not least, hook up complete to the return node. And the other thing I'm going to do here, it's just good practice. I'm going to hook up the array element to isValid. We're going to do an isValid check, the question mark. Connect this up just like this, and only if it's valid, move on. These I'm going to move down a little bit, move this down here. So if you've got that entire function, get closest acquisition, it's doing all this stuff, compile and save. We'll go back to our event graph. Now what I'm going to do here is I'm going to duplicate our current target because we need two different paths now for aggression follow player versus acquisition. So I'm going to connect up the true down here. This one's going to be connected up here, and I'm going to move all three of these over because now we can right click, we can say get closest acquisition, the pure function. And we're first going to check to see before we actually update our closest acquisition, we got to check to see, is it valid? Because maybe we don't have a closest acquisition. So only if it's valid, then we're going to connect this up like this. And this one down here will also connect up has line of sight. So basically what it's doing here is it's updating all potential acquisitions, and then if we can acquire, then it goes on and it gets our closest acquisition, and then it sets that as our current target and establishes line of sight. So we'll compile and save this, and now we have to go back to our adversary AI character, and the last thing we have to do in order to set this up is in our attempt to pick up ability function. So I'm going to zoom out here. It's this all the way at the end of the attempt to pick up ability function. Because what this is doing is it's clearing out our current target completely, and we don't want to do that. What we really want to have happen is after we pick up an acquisition, we want to check to see, okay, is there another acquisition that we should be picking up? So to do that, we're going to delete out these four. We're going to keep our AI controller reference because instead what we're going to do is we're going to get our potential acquisitions, this array, and we're also going to get under our local variables, the local gameplay ability pickup, because what we just picked up, the first thing we've got to do is we got to remove that from potential acquisitions. So remove item, connect up our local gameplay ability pickup, move this up here, connect this up. But then the next thing we have to do is from our AI controller, we have to get our closest acquisition. So after we remove it from the array, we can get the closest that still is in the array. And also from our AI controller, we are going to set our current target. So set current target, this one down here, connect this up. Our current target is going to be get closest acquisition. But again, we want to make sure it's valid before we set it. So we're going to check to see, is it valid? Connect this up, connect up is valid here, and then if it is valid, set it as the current target. And the last thing, we have our current target on our character as well. And I know this is confusing, but we got to make sure to set both of these. So get closest acquisition, same thing. And the last thing we're going to do, if we successfully update our targets because it's valid, because our closest acquisition is valid, then we're also going to say we have line of sight. So I'm going to get a new reference to our AI controller, and I'm going to say, okay, we've got line of sight, has line of sight. And what this function does is it basically updates our Blackboard values. So if I go into that, I just want to show you. Yeah, so these are all the Blackboard values that are updating where our character is actually going. So back to the BP adversary AI character. Has line of sight, if you've got all that. So after tags here, it's first removing our local gameplay ability pickup, then it's getting our new closest acquisition. It's checking to make sure, is that valid? Do we have a closest acquisition that we can actually pick up, or has every acquisition been picked up? And only if it's valid, then it sets our new target, and then we say, okay, we have line of sight. And this is what updates our Blackboard so that the AI character heads in that direction. The last thing I'm going to do here is I'm going to collapse the end of this all down to a function. So I'm going to start with our AI controller back here, get closest acquisition. This is valid, the set. Also, any reroute nodes that are part of this, you have to select in order to collapse it to a function. I didn't know that until right now, but you have to select that. And then right click and collapse to function. And it does this weird thing where the AI controller reference is coming out to the potential acquisitions. So instead, I'm going to get our AI controller reference, plug it in here, connect it up here. And then if we go into this new function, well, first I'm going to right click on it. I'm going to rename it, and it's going to be reestablish, capitalizing the E in establish, closest acquisition. Enter. And you know, from time to time, I notice functions just randomly get a space inserted in there. So I'm going to rename this that we set up, I think it was 2 episodes ago. Strongest ability, activate check, get rid of the spaces. All right, so let's go into our reestablish closest acquisition function. And what we can do is we can disconnect this because the AI controller reference, I think if I just hit X there, we delete that. And then I can actually delete out the return node completely. So we'll compile and save this. If that's looking good, we'll go back to our attempt to pick up ability here. And there's one last function that we're going to bring in here. So we'll get our AI controller reference, and I'm also going to clear recently detected. And I'm going to do that right before we reestablish our closest acquisition, if we have one. Connect this up here. And the reason we're doing this, so this, if we go back into our behavior tree, just want to refresh your memory on the behavior tree. So this is affecting the recently detected target, this EQS query, the move to location. Because as it stands, after we pick up an ability, this current movement goal location, last known target location, it's going to be where that ability was. But it's no longer a relevant location once that ability is picked up. So that's why we're clearing it after it's picked up. So we'll compile and save, and now let's test this, but let's have our behavior tree open. So I'm going to make it in the side here, and I'm going to zoom out a little bit, but this way I could see the entire behavior tree. And now I'm going to test with my actual third-person character. So I'm going to right-click next to an ability and play from here. And make sure to pick up an ability before the AI picks up the ability. So if he's running at, so right now he's running at the closest ability, which is the air here. So that's looking good, but watch what happens if I pick it up. So he's still running at it. He's still running at that same location. It's not until his AI perception actually updates that he goes to a new location, that he goes to the next ability. And one unfortunate thing about AI perception, and I haven't found a way around this, is it doesn't actually update when one of the actors that it's perceiving changes. And I don't know of a way of forcing that update either. So if you know, please post in the comments below. So instead, what I'm going to do is I'm going to run a function every half a second that's going to identify potentially inert acquisitions and then remove those from the array. So if we navigate over to our adversary AI controller, we're going to create a new function on here. Plus sign, we're going to call this identify inert potential acquisitions. And I'm going to move over here. We're going to start with our potential acquisition array, get, and from here, we're going to do a for each loop, connect this up. So from our array element here, we're going to check to see, okay, does the actor have tag? Actor has tag, and the tag is inert. And then if this is true, if the actor has that tag, then we can connect up our loop body here, and we can get our potential acquisitions array, get, and we can say from here, remove item, connect up true to there. And we've got to connect up our array element to here, and of course, we're going to put in a reroute, a couple of reroutes, another one down here. And then on completed, what we can do is we can reestablish the closest acquisition. So we can call that same function that we just created, reestablish closest acquisition. And this is going to run every 0.5 seconds. So on completed, we can get our possessed pawn because that functions on our adversary AI character. And then from there, we have to cast to our BP adversary AI character, connect up completed to here. And then as BP adversary AI character, reestablish the closest acquisition. But there's something important here, which is it's potentially the case that our AI character would no longer be in acquisition mode. So in this function, this reestablish closest acquisition, let's actually make sure it's in acquisition mode. So I'm going to go into that. And the first thing I'm going to do, move over to the purple here, AI controller reference. From here, we're going to get our short-term mode. Get short-term mode. I'm going to move this down a little bit, move this in. And we're going to check to see, okay, is this equal enum? I guess I have to move these 4 down, make some space, and these 3 over. Is this equal to acquisition and branch? Because only if we are in acquisition mode, if our character's in acquisition mode, do we want to actually get the closest acquisition and set that as the current target. Because by the end of this episode, we're going to be toggling from acquisition over to aggression. So compile and save this. And the last thing we need to do is back over to our adversary AI controller. So we actually need to call this function, identify inert potential acquisitions. And I'm going to call it every 0.5 seconds. And it's kind of going to be cheating a little bit. And I say that because our AI character is not necessarily going to see the acquisitions that it's then flagging as inert. So imagine it saw an acquisition on one side of a hill, and then the AI character goes to the other side of the hill, and then our player character acquires that acquisition, but it's not in line of sight. So our AI character is still going to know that that acquisition was acquired and can no longer be acquired, even though technically it's not in line of sight. You could do line traces to make sure it's actually in line of sight, but I figured it's only cheating a little bit, and if it really becomes a problem, like if I notice during gameplay that it really feels cheap, then of course we'll revisit it. So after this set short-term mode acquisition, we are going to set timer by function name. I love this. Do this all the time. So right click on identify inert potential acquisitions, copy that verbatim, paste that in the function name, hope that no spaces suddenly get inserted for no reason. We're going to set the time to 0.5 seconds, looping to true, compile and save. All right, so what I'm going to do here is once again, I'm going to put this into window mode, and we are just going to simulate, and we're going to watch it acquire all the abilities and see what happens. So let's watch that simulate. So it's going after the closest one in each event. That's pretty good so far. Looking around, found the last one. So once it got that last one, it kind of sat there, kind of stuttered for a little bit. So why is that happening? How can we solve that? So if we go back into our adversary AI character, I'm just going to expand this again. So what we need to do is if our get closest acquisition is not valid, so if it doesn't have a closest acquisition because it doesn't see any acquisitions, then what we can do is we can get another reference to our AI controller, and we can say clear sensed target and connect this up here. And I'm also going to, right after that, clear recently detected. So this one right here, and connect this up. So compile and save this, and we'll do one more test in simulation mode. So over to our behavior tree, simulate. Moment of truth, let's see what happens. Yep, and it's instantly back over to patrol mode as soon as it acquires that last acquisition. So then let's retest with our player character. So I'm going to do a play from here, and as soon as it starts running after this acquisition, let's see what happens. All right, so it's running after the fireball. If I get the fireball, it instantly changes targets to the next closest acquisition. Let's see if I get it first. Nope. Nope, it beat me to it. Now the only issue is that our AI isn't yet using the speed boost, but we're going to cross that bridge soon enough. So now we're going to pivot and talk about AI tactics a bit. So our AI knows when it picks up the closest ability, or if another character picks up that ability, it knows how to quickly shift targets and go to a new ability. And from the last two episodes, it knows how to aim those attack abilities, and if our target gets too close, then the AI will switch over to its short range attack. But to get our AI attacking in an intelligent manner, there's still a few big pieces remaining. So one is, how does our AI calculate when to switch from acquisition to attack mode, and then back to acquisition mode? And that we're not going to cover this episode. That's going to be an upcoming episode. But even before that, and this is what we're going to work on the rest of this episode, we need to figure out where our AI should attack from. Like, what's the ideal distance from which to attack? And there's really two questions that are enclosed within that single question, because there's the distance, there's the range that the AI should attack from, but there's also other considerations for AI positioning. So geography, or maybe there's other things that they can acquire close by. And both of these questions here are difficult to answer. But the second question, it's a little bit more complicated, so we're not going to cover it yet this episode. But we're going to get there as we continue to refine and update our AI. And for the first question, it's pretty simple right now, simply because we have two abilities. We have a short range ability, doesn't work further than like 10 meters out, and our fireball, our long range ability, which can work all the way across the map. But there's still an optimal range for the fireball, right? Because there's a range at which the AI can aim and probably hit its target because the target can't react fast enough to get out of the way. So we got to figure out, okay, our AI is not going to be literally on top of the target. How does the AI position itself to be an optimal range away from the target? So our AI is here, targets here. And the truth is the optimal range is like a sweet spot donut. So there's a minimum optimal range and then a maximum. Past that point, it's going to be easy to dodge the fireball. But we don't want our AI to always run directly at the target, right? We want to give it some variability, and that's where EQS is going to come and play. And this setup with EQS relative to the target, it's only going to work when our AI is in aggression mode, because if they're in acquisition mode, they're just going to get the ability. They're going to run straight at it. Now later on, we might create more complicated behavior where the AI can zig and zag toward its target as it's dodging abilities, but we'll get there when we get there. So the first thing we got to do is we got to set up an easy mechanism for the AI to be able to switch modes. And for now, it's going to be us toggling that from acquisition to aggression mode. But later on, that's what our AI is going to have to calculate to figure out which mode should it be in at any given moment in time. So let's start the setup of this by going back to our behavior tree, because there's going to be specific paths in our behavior tree that are only taken if the AI is in a specific mode. And for that, we need to give our AI, our Blackboard of our behavior tree, a new enum that's going to store what mode it's currently in. So if we go over to our Blackboard up here in the top right corner, we're going to create a new key, and there's an option for a key type of enum. And I'm going to name this the short-term mode, exactly what we've got on our AI controller. And over in the key type, we can expand this. And for enum type, we can make this into our AI mode. So AI mode enum that we created, I think it was 3 episodes ago. So now that we've got this variable, so this is going to drive behavior in our behavior tree. But first, we need a function on our AI controller that's actually going to switch the mode. And then we can call that function whenever we need to, whenever it's appropriate to switch the mode. So if we navigate back to our adversary AI controller, we're going to create a brand new function. Starting to pile up the functions, we're going to sort them this episode, but we're going to name this one change AI short-term mode. And this is going to have a single input, so a plus sign here. We're going to name this input AI mode to change to, and it's going to be of type AI mode, that right there. Then I'm going to move this over to the left because from this, we are going to switch on AI mode. And there we've got our modes. So whatever mode is passed into this function, it's going to set our short-term mode. So we're going to set safety to safety. And then all I'm going to do is I'm going to duplicate this 4 more times. Put them right against one another. So 5 total. This one's going to be exploration. We go right down the list. Acquisition, and then aggression, and then follow player. Connect these up. 1, 2, 3, 4, 5. I'm going to center them a little bit. There we go. And then the last thing we need to do is we need to get a reference to our Blackboard. So I can right click, I can search for Blackboard, scroll down to the bottom under AI, get Blackboard. And then from Blackboard, I can drag out a pin and set value as enum. And then every single one of these is going to be hooked up to the set value as enum. But first I'm going to put in a reroute right there, hook them all up to the reroute. And the reason we can do that, the reason we can hook up all of these is we can make a literal name of the key, make literal name, and that's going to be exactly what we specified over here on our Blackboard. So this is short-term mode. We got to put that in verbatim. So short-term mode. I don't know if capitalization matters, so make sure to get that right. And then the enum value is going to be whatever we set here. So we could just take our short-term mode, get, and connect it up here just like that. So now compile and save. And to get ready for testing, we have to go back into our third-person character, because on our third-person character is where we're actually going to trigger the switch over to aggression mode. And we already have this for X, so we're just going to build on this right here. So we'll take our AI controller and move this over. The last thing I'm going to do here is just drag out a pin, and we are going to clear sensed target. And that's going to make it easier for the AI to then switch targets because it's clearing its already existing target. And then a very similar thing, we're also going to clear recently detected. So this one right here, and connect these 2 up. So now we got it for X. Compile and save, and we are going to watch our behavior tree as we play. And play pretty close to the AI. So maybe right around here, right click and play from here. All right, so our AI is acquiring targets. And what should happen is when I hit X, it should go after me. So here we go. Okay, so it just lost its target, and now, there we go. It's attacking. And when it gets close, boom. But the problem is, it's not yet positioning itself relative to me, right? It's just running straight at me and launching every attack under the sun, which is fine, but it's a little aggressive for a first date. So now that we have a way of switching the mode, now we can set up our attack positioning. So we're going to start by creating another key over in our Blackboard. So we already got our short-term mode, which we're not yet using in our behavior tree. But let's go back to the Blackboard. I'm going to expand this. We're going to do a new key here. This one is going to be a vector. And we're going to name this the current movement goal location underscore optimal attack location. Sorry, there's 2 underscores in there because we're mimicking the previous setup that we've done. Basically, what this is going to do is that the EQS query is going to run based on our target's location. It's going to get locations in a donut shape. It's only going to get the locations in the half of it that's closest to its target. But then based on the best location that it gets, then it's going to set this optimal attack location. But it's only going to set that if short-term mode is set to aggression. But before we do that, we got to set up all the EQS stuff that we need. So we got to go back to our content drawer, back to AI, into the EQS folder here. In this, we started in episode 50, our first EQS episode. So we're going to duplicate EQS find target, duplicate this. We're going to name it EQS underscore aggression, because it's only going to apply in aggression. Find optimal attack location. And then we're also going to duplicate EQC get last known target location, because we're going to make an even simpler one. So EQC get target location. It's not going to be last known target location. It's going to get its target location that it has currently. So we'll go into that. So we'll go into the provide single location function that we set up in episode 50. And what we're going to do, zoom out a little bit here, make some space over to the left. We're going to switch this make literal name over to current target and make sure this matches verbatim what you got on your Blackboard here, this current target here. Back to EQC get target location, current target. And instead of get value as vector here, that's not going to work for an actor. We have to get value as object, and then we can hook up the key name here. And then from get value as object, we're going to drag out a pin, and we are going to cast to BP third person character. So not a BP third person character, this middle one, cast to BP third person character, and then connect this up here. And then instead of getting our vector here, what we're going to do, I'm going to move this into position. We are going to get our actor location, and this is going to serve the same way as get value as vector does. So we're going to connect it up here. We're going to connect this here. We're going to connect this over here. And then we can delete out get value as vector here, move this into position. So we are all set for get target location. We will compile and save this, close out, and then we'll go back to our content drawer and go into EQS aggression, find optimal attack location. So this part of the episode is the easiest to mess up. Make sure you get this right. So instead of simple grid here, what we're going to do is drag out from root, and we are going to get points in a donut. Now, for whatever reason, when I was testing this out with EQS debugging, it did not show the points. So only the simple grid is generating the actual circles around the target. I don't know why the donut's not working, but if you know of an easy way to fix that, please let me know in the comments below. But regardless, I found I was able to get it working even without debugging. So the first thing we're going to do is we're going to adjust our inner radius and our outer radius. And I just figured this out through trial and error, like the optimal positioning for the fireball. And I found that the inner radius of 1000 and an outer radius of 1500, which is about 10 meters to 15 meters away, that worked out really well. It was really hard to dodge the AI's fireball attack. Now in the long term, these are going to be bound to different variables that we're going to change depending on the attack of the AI. Because if the AI has an attack that's moving slowly, we want to be closer. But if the AI has an attack that's moving even faster than the fireball, then the optimal range could be even further away. And that's going to be where we attach these to the data binding here, but we're not going to have to do that this episode. So the arc angle here, we're going to set this to 180 because we only want it to be the front half of the donut. And then we have to expand the arc direction up here. And we can keep 2 points here. It's going to be from the querier to its get target location here. And what this is determining is the 180-degree arc. Basically, it's saying the 180 degrees in the donut, that's between our target location and the querier, which is our AI. I'm going to update this points per ring up here up to 30, and so that way the AI can get up to 30 specific points to choose from. And actually, it's 90 points because it's 3 rings that it's doing in that range. I think as long as we're in single or double digits, we're totally fine here. I'm going to expand the projection data because we are going to do a trace. Very similar to this one, we're going to do a trace of navigation. In the extent X, I just extended this a little bit to 10. I'm not sure that that matters, but I ended up with that in my final product, so let's do it. And then the post projection vertical offset, we talked about this with the EQS episode, but this is like where to project from. And I'm going to set this to be 50 because our AI is looking roughly 50 units like head level compared to where the capsule is, which is at waist level. All right, so now that's looking good. So now I'm going to take my distance to querier here. We're going to copy that. This one we're going to copy first. And then we go over to donut and Control V and paste it. But now instead of scoring equation being linear, like preferring a greater distance away because we were using this when we were searching for a target, this is going to prefer the shortest distance. So the scoring equation, we're switching from linear over to inverse linear. So then it says prefer lesser. Now the last thing we're going to do is select this trace to querier on visibility, copy that, Control C, select the overall donut, paste. And this one, instead of tracing the querier, we are going to trace to our get target location. And just make sure everything here looks the same. Distance to querier, make sure all this looks the same. The donut, make sure this looks the same. Very easy to get one of these settings wrong. So let's delete out our simple grid. Won't need that anymore. And that's our new root. So let's save this and now over to our behavior tree and behavior tree here. So what I'm going to do is I'm going to take everything we have currently and I'm going to move it all down because what we're going to do is do a new selector right over here. And actually, what we can take is everything here that already has a run EQS query. We can copy that and we can paste it right over here and then attach this up, because we're going to update all three of these nodes. But this path is only going to be taken if our AI is in aggression mode. So the way we're going to do that is, instead of using recently detected target as a Blackboard value, and this is a decorator, so I can right click and I can say add decorator if you want one up here. But instead of that, what we're going to do is we're going to set this to be our Blackboard key short-term mode. And we're going to say if short-term mode is equal to aggression, and I'll change the node name. So I'm going to call this if AI is in aggression mode, be aggressive, be aggressive. No more singing. Okay. Then we got to run the EQS query. And instead of current movement goal location, last known target location, we have to update our Blackboard key to our optimal attack location. And the other thing I did here, and you could try this out, test it out. Let me know what you think in the comments below. The run mode here, instead of single best item, I selected single random item from best 5%. You could also try 25%, see what you get, but let's do 5% right in the middle. In this way, out of those 90 targets around the ring, it gives the AI some randomization in what it picks, but not a ton of randomization. And then last but not least, instead of the move to current movement goal location, last known target location, we're going to change that as well to our optimal attack location. And I'm going to change the name of this EQS query. So it's going to be run EQS query get location to attack from. The last piece of setup that we need here, and I only got to this through trial and error, is we need a decorator that ensures that our current target is in fact a character. Because if our AI is in aggression mode, but it doesn't have a current target, then it's just going to sit there and it's not going to know where to go because it doesn't have a target. So what we're going to do is, back in the content drawer, back in the AI folder under BT decorators, we can duplicate BT decorator target in air. So right click, duplicate, and we'll call this BT decorator. I'll delete the second half. I'll call it target is character. And then we'll go into that. And we'll go into the perform condition check AI function. And this is going to be a really simple change. So all we got to do here is delete out anim BP is falling. And all we're doing is casting the BP third person character. If it is a character, it's going to pass the check. If the cast fails, or if our current target is not valid, then it's also going to fail. And that's it. Everything else is going to do exactly the same. So compile and save this. We are done with this. Back to our behavior tree. And all I'm going to do is add a second decorator like so. So add decorator. It's going to be BT decorator target is character. And we're going to set both of these. If AI is in aggression mode and BT decorator target is character, set both of these to observer aborts both. And this one too, observer aborts both. Easy to forget that. And I'm going to change the name of the sequence node to instead be get attack location. Let's do get optimal attack location and move to it. There's one last thing we have to do before we test, and I found this through a lot of trial and error, but back in episode 49, we created this function called isStuckCheck, and we also need to update our movement goal location optimal attack location if our character gets stuck. So that's back in our adversary AI character. And if we expand under AI movement here, we've got our isStuckCheck. And I'm just going to move this over. And in general, what I found in this function just through testing is that expanding the get random reachable point in radius function radius, expanding that to like 1,000 instead of 100, it basically ensured that every time it would unstuck the character. Whereas 100, it's not that far away. It's literally 1 meter away. So this one too, we're going to set over to 1,000. And the last thing we got to do is we got to take all of this stuff right here. So copy all of these nodes, paste them over, and connect it up just like this. And this is where we've got to update our key names. So I'll go back over to my behavior tree, Blackboard, and we're going to right click on here, rename, get that key name verbatim, go back to our adversary AI character, paste it in the make literal name there. Right down here, same thing. So this should be current movement goal location underscore optimal attack location for both. So compile and save this, and make sure you've compiled and saved everything. And we should be ready to test, but we are going to watch our behavior tree. So let's go back to our behavior tree. I'll make that into a window just like this. We don't have to see the individual node names. We just need to see where it's actually going. And then what I'm going to do is right click, play from here. Currently he's getting his targets. And now I'm going to switch him over with X to attack mode as soon as he gets this fireball. All right, I switched him over, but he still has an existing target. And now he's over to me. And something's wrong, because if I look over in our behavior tree, the AI is not in aggression mode. You see over there in the bottom right hand corner, can't move all the way over there, but it says short-term mode is safety. So it's still attacking, but it's not going into aggression mode. And the reason is because on our third-person character, we've got short-term mode aggression here, but it's not actually updating the behavior tree because we're not calling the function that we just created. So we just created on our AI controller this change AI short-term mode function. So back in our third-person character, instead of this, so we'll get rid of this from our AI controller reference, we are going to change AI short-term mode. Hook this up here, change this over to aggression. And you know what? Instead of X, I'm just going to do keyboard V for vendetta. And connect this up just like that. We're going to do V instead. Compile and save. And then back over to our behavior tree and zoom out a little bit and then right click, play from here. All right, V. And you see that both of those decorators are now yellow. So as soon as the AI sees us, as soon as he turns around, he should be coming after me. He's running wildly in the wrong direction. There we go. So now he's set a target location. Let's see what happens when I get too close. All right, over to flamethrower. Now here's the problem, right? When the AI starts running in the wrong direction, he's not shooting at us because he can't turn sufficiently in the direction that he needs to. He's looking at us. We see him actually turning and looking. But he's not shooting at us because he's turned, well, too far in the wrong direction because he's trying to get in that donut arc if I run at him. Yeah, just like that. So how do we fix that? So I was thinking about this problem. I was thinking about it. And I was like, man, do we need to break our AI's rotation such that it can rotate in a different direction from which it's moving? And I didn't want to do that because it just doesn't look natural. But then I had an idea. And the idea has to do with what I think will be a technique in the game that we're making, a stratagem. And the stratagem is I can run in one direction, and then I can turn and I can fire the fireball in an opposite direction. So when I jump, my velocity is in one particular direction. And couldn't we have the AI do that, right? So couldn't we have the AI jump if it's not sufficiently turned in that direction? And then after it jumps, maybe like 0.2 seconds later, right, it calls the function again. And if it's in the air, then it turns, it rotates in that direction and shoots the fireball. To do that, we're going to go back into our BP adversary AI character, into the attack check function. And I'm going to zoom out here. We're going to come back over to the left. And all of this stuff right here, we're going to move it down and over to the left a little bit. All of this over here, we're going to move to the left. The very first thing is over here, the absolute value less than 90. I found this worked great if this was a lower value. So we got to lower this down to about 45 degrees, meaning our AI character is going to jump if the angle is greater than 45 degrees. So then what I'm going to do, coming down here, we're going to get our capsule component, get world location, and then drag it a pin, and we're going to find the look at rotation. And a look at rotation is going to be from here, this plus sign right here, connect it up. And then right click on return value and split the struct pin. So this is finding the look at rotation between our world location and where our target is going to be, which is this. So we're going to leave this as is for now. I'm going to come up here. We're going to take this branch. We're going to move it out. And instead of connecting the false here, what we're going to do is we're going to connect this false down to another branch. And this branch is going to be based on whether our character is currently jumping or whether it's currently falling. So we're going to get our AnimBP reference, AnimBP, and we're going to get whether or not it's currently falling. Get is falling, and then connect this up here. And that's the simple indicator that tells us if it's already jumping. Because if the character is currently jumping, what we're going to do is we're going to drag in a reference to our character movement component and get a reference to orient, rotation, and movement. And we are going to set that to say, no, we are not going to be rotated according to the direction in which we're moving, but only if we're already currently jumping. Now, if we're not currently jumping, that's this false, then we are going to jump function right there. I'm going to take this find look at rotation. We're going to move it up right here. Move the jump down a little bit. Move over. Because now we have to set our adversary AI character's rotation based on this. And specifically the Z value. Because the Z axis is this. It's up and down. So it's going to determine, do we need to set it to the left, to the right? And it's based on where we need to look at to get that target. So right here, we're going to right click and say set actor rotation. And the set actor rotation is our BP adversary AI character. So we can connect this up. And what I'm going to do is right click, split this, and connect up Z to this. Now we can't just set the X and the Y to 0, so we have to get our current rotation. So get actor rotation, and we can split this, hook up the X and the Y, because those are not going to change. And I can put in a little reroute node right here. And I'm also going to set this to teleport physics, so it doesn't do any damage to instantly rotate. Okay, so to back up, just to explain this a little bit. So what it's doing is it's checking to see, okay, are we currently rotated within a 45-degree arc, really a 90-degree arc within our target? If the AI character is not currently rotated within 45 degrees of where its target is, then what it's going to do is it's going to come down here and it's going to check to see, okay, is our AI character falling? If it's not falling, it says jump, because what's going to happen is this attack check is going to get called again 0.1 to 0.5 seconds later. And 0.1 to 0.5 seconds later, AI character should then be in the air. So when it is in the air, what's going to happen is falling is true. It's going to say, okay, normally you are rotated to wherever you're going, but now that you're in the air, stop rotating in the direction that you're going. But where should I rotate to, says the AI. So what we're going to do is get our AI actor's current rotation, and we're going to rotate to the Z axis, wherever the look at rotation to our target is. I hope this is making sense, because this is literally the most complicated blueprint logic we've done thus so far. So then after it rotates to its target, then what should it do? So then what I'm going to have it do is it's going to assess, should I use long range or short range attacks? So then I'll take this pin right up here and connect it to this branch, because once it's rotated at its target, fire at will. Now this unchecking of orient, rotation, and movement, it's going to have some weird effects unless we check it again, because once the AI character touches down on the ground again, they're still going to be rotated in the direction of the target. And so if you want an effect where he's sort of like ice skating as he's walking over the hills, but we're not going for that. So we need to set orient rotation back to movement as soon as he touches the ground again. So the easiest place that I know to set that is over in our animation blueprint with our footstep effects. So we'll compile and save this, and we'll go back over to our animation blueprint. So back over to content, core, ABP third person character. And we'll go over to the event graph and zoom out. Come down to our anim notify left foot plant and right foot plant. And we'll just make a little bit of space here. So all we got to do is come down, get for our references the third person character. Specifically, we need to get the movement component down here, get character movement. And then from character movement, we need to orient rotation to movement. So set that, connect this up. So as soon as he takes a footstep, it's oriented. And we'll copy all of that and we'll paste it also down here under the right foot plant. Paste that in. Same thing. Connect it up, connect it up. So compile and save our ABP third person character. We are all set here. We're also all set in our EQS aggression find optimal attack location. The last place that I found to be useful in setting that setting for orient, rotation, and movement is at the very end of our gameplay abilities, like when we're deactivating a gameplay ability. So back to the content drawer, and we'll go over to our blueprints into gameplay abilities, and we'll do this in the parent gameplay ability. Whenever any gameplay ability is deactivated, then it'll go back to orient, rotation, and movement. So we'll go back over to the event graph, and what I'm going to do is come down here to deactivate ability, and then right after able to be activated or deactivated, this is where we'll set it. So we'll get our owner character reference here, drag out, get character movement, move this over a little bit, and from here, orient, rotation, and movement set, and set that back to true. And this is specifically when we're deactivating any gameplay abilities. Compile and save. So let's test, and we don't even need our behavior tree up and running. So I'm going to right click next to the fireball, play from here. I'm going to full screen this just for fun. So select V or whatever keyboard button you set it to. And I'm going to go into acceleration mode here with our air and speed boost, just to show you what our AI can do. You know, right here, right now, honestly, feels to me like we got the start of a game. This is the episode where it feels that way. AI is still not perfect, right? It's still making mistakes, it's missing me, it's still aiming off in the wrong direction from time to time. It's still aiming such that it could hurt itself because it just aims right into the hill. We gotta take care of that, but honestly, it's starting to feel like a game. But we still got a couple of issues, right? Because the flamethrower can still be activated midair. So let's take care of that. And this is another issue you might see. And I haven't been able to get this to replicate doing the recording now, but I took a screenshot of this when I ran into it just in case it popped up for you. Let me show you how to fix that. So we actually have to go into our animation blueprint. So back over to Content Core, Animation Blueprint here. And what's causing this issue is our assess, adjust, aim function. And specifically, it's the fact that we could be getting a reference to our current target, and we might not have a current target when the assess, adjust, aim function is active. So all we got to do is we got to add another isValid check. And this is right here on the overall graph. So I'm going to zoom in and we're going to do an isValid just like this. One more isValid check. And then from isValid here, connect up to isValid down here. And just to clean this up a little bit, isValid directly here, get rid of one of the reroutes. This is pretty messy, but I hope we're nearing the end of needing to make updates to this function. And we'll clean this up a bit by the end of the episode. So compile and save this. And now let's fix the issue where our character can use the flamethrower in midair. And for that, we got to go over to our third person character. So back in episode 37, the issue fix episode, we created a function under gameplay abilities. Ability can be activated or deactivated, this function right here. And since that episode, we've updated this logic a bit. And I think I said that this is pretty complicated. It's messy. At some point, we need to clean it up. We're going to clean it up a little bit right now because basically we need to create a similar function that our AI can use. And what I'm going to do is instead of this overall function being used by the AI, we're going to consolidate just this piece of it down to a separate function. And that's then going to allow us to pass in an ability into that new function that our AI can assess. Can that ability be activated or deactivated? And so if our AI character is in air when it tries to use the flamethrower, not going to work. So what we're going to do, if I zoom out here a little bit, not the get here, but everything else. So everything to the right of the get. So all of this stuff, we're going to right click and collapse it to a function. And then it does that. And there's a ton of input pins, but really all of these are a single input pin, which is the gameplay ability that we're passing into it. So we double click on that. I'm going to move this over here. This I'm going to move in a little bit. Return node, I'm going to move up and in. This I'm going to move in here. All right, so then all of our input pins here, we've got two objects, a whole bunch of gameplay abilities. What I'm going to do is just exit out the two objects. I'm going to take the very first gameplay ability input. We're going to keep that and reduce this all down to a single input and just call this the gameplay ability. And then we got to connect this up to every single pin. So connect it up here, down here, connect it up there. Fourth one down here. Actually, it's the fifth one. And then there's another one down here. I think there's 7 total. 1, 2, 3, 4, 5, 6 crossing the streams again. Just 6, I think. So now I'm going to rename the function. I'm going to rename over here. We're going to call it meets requirements to activate or deactivate gameplay ability. That is a mouthful. And then if we go back to our ability can be activated or deactivated function, yeah, so that's not looking so good. So we just need to hold Alt and left click and disconnect all those. Nope, no reroute, disconnect that, and that's looking better. Drag that in. Oh, the last thing we need to do is this return value. So for the meets requirements to activate or deactivate gameplay ability, the return value here, we're just gonna say can be activated or deactivated. And that's going to return a true or false. So we'll compile and save this. And then let's go back to our adversary AI controller. And specifically what I'm going to do is go into the get strongest gameplay ability that we set up last episode. This function right here, get strongest ability in array. Because when we get the strongest ability in array, that's where we're going to check to see, okay, it might be the strongest ability, but maybe we can't activate or deactivate at any given moment in time because, for example, the character's floating in air. So really what we need to do is we need to get the strongest ability in the array that can be activated at that moment in time. So in addition to being valid, so this is where we're going to add that additional requirement. So I'm going to move this over, and also these two variables. I'm just going to move them over here. And I'm going to connect this reroute up to the target just like this. So we're going to drag in a reference to our possessed pawn here, get, and then from our possessed pawn. So we can't call the function directly. We can't call this meets requirements to activate or deactivate function directly. And the reason is that our possessed pawn is just a pawn. So really what we have to do is we have to cast a third person character. And we have to make sure that our possessed pawn is a third person character, and it is. And then once we do that, then we can call the function. So I'm going to create a little bit more space, just a little bit. And then I can drag out a pin here and say meets requirements to, wow, that is a long function name. Sorry about that, guys. Drag this over. We got to create more space because what we got to do is we got to say, okay, if this is true and this is true, meaning it is actually the strongest ability in the array, So these two both have to be true. So I'm going to move these back over, this one over here. If these are both true, connect up to the branch right there. Connect this up right here. Now we still have to link up our gameplay ability here. So from this pin right here, link up right there. So if you have all this, you're all set, because what it's doing is when we pass in a gameplay ability array, it's first checking to see, okay, every element is valid, meaning there is a gameplay ability in that spot in the array. And then it's checking to see, okay, does that ability meet the requirements to activate or deactivate the gameplay ability? And if that's true, and it's also the strongest gameplay ability, meaning the intensity is greater than the local strongest intensity, which is 0, then it's true. And then we say go. So let's compile and save this, and let's test again. Feels like I'm being owned by my own creation. Maybe I made this thing a little bit too powerful. So now he doesn't use the flamethrower when I'm very close, unless he's actually on the ground. Let's see if I can get him. Oh, there we go. He's on the ground there. Yep. All right, so as we do at the end of every episode, guys, it's almost ritualistic at this point, cleanup time. And for this episode, we have a ton of cleanup, because really we're doing cleanup for the last 3 episodes. So let's start in our animation blueprint. This monstrosity of a function, this assess aim function, we're going to simplify this at least a little bit, because we've got this part down here, and then we also have this whole part. So not this stuff, but everything from this pin on down. This is our AI stuff. So let's start by collapsing all this over here to a function. So I'm going to select all this, right click, collapse to function. And we're going to call this reset spine rotation. And then I'm going to zoom out. We are also going to collapse everything from here. I'm going to hold control over here, drag this all down. All of this stuff. And then I'm going to right click and collapse to function. And this one is going to be right click, rename AI character aim. And then we can bring this in considerably. And that's much cleaner. This in too, much cleaner. Get rid of this reroute, connect this up. So now we have 3 AI functions on our animation blueprint. We're starting to pile up functions that are not categorized. So 3 is my threshold. Let's give them a category of AI. So right up here, just type AI. Actually, let's specify AI character. And we'll do the same thing with the 2 other AI functions. AI character, this one here, AI character. And these 2 also, the assess vertical impact force and damage and general impact force and damage. We're going to be doing a lot more with damage in the near future. So I'm just going to switch these over to damage. Damage. Joe DiMaggio. All right, looking good for our animation blueprint. Compile and save this. Taking a while to compile. There we go. And then we can close out of it. So next one is our adversary AI character. One thing to check from time to time, I notice Unreal Engine doing this, and I don't know what causes it, but periodically I see Unreal Engine inserting spaces into function names. So if you know exactly what causes that, please let me know, but I always have to double check and just make sure, especially if I'm doing the set timer by function, that gets messed up if I ever get the name changed accidentally here. So if you find a function not working, that's the first thing I would check. I would just check to see, okay, is there an extra space in there that got inserted somehow? Because on occasion that definitely trips me up. And we'll zoom out on the attack check function. So this is starting to get pretty messy, but I think we're going to make this a lot more sophisticated, to be honest, because our AI needs to check a number of things in relation to attacking. So we're going to keep it expanded for now, but what we can do is at least comment stuff. So I'm going to select the bottom portion here. We're going to do C, comment, and I'm just going to zoom in so you could actually see this. We're going to check to see if the AI is already aiming generally in its target direction, plus or minus 45 degrees, and that's this right here. One thing I'm also doing, and this is going to be way, way down the line, but I'm keeping track of variables that we could adjust to give our individual AI characters personality. Because eventually we're going to have things like a free-for-all mode and a team mode, etc. And I want each AI character to have some things, like some individual attributes that give it style, give it personality. And I think this is going to be one of those variables, like how often it attacks, like is it 0.1 to 0.5 seconds, or maybe it's 0.2 to 0.3, like it's more consistent, stuff like that. So just to give you a sense of where we're going in this series. So then I'm going to zoom out, and actually what I'm going to do is I'm going to shrink this comment down to about there. And then for this section right here, we're going to add a comment. And this one is going to be, if AI is not already aimed in the direction, then jump. If already jumping, then turn toward the target in midair and attack. And the last piece, I'll zoom out, highlight this piece, C, and this one is going to be AI attack type discernment based on range to target. So if you got all that with those comments, like I said, this is going to get adjusted further, I'm sure, over time. So compile and save. We are all set with our adversary AI character. So we'll close out of this one. We're also all set with the behavior tree and Blackboard. We can close out of those. Next, onto the adversary AI controller here. I think we're now at the point with enough functions and variables where it's time to start classifying. So each of these 4 variables that are all gameplay ability arrays, we're going to give them a category of gameplay ability array. But let's simplify that. So let's just call it ability array. Do the same thing for the other 3. But Neil, you've got spaces in your categories. Yeah, I guess I'm inconsistent. All right, so then for our functions, we're going to create another category, and this is going to be starting with gameplay ability intensity boost. Going to give that a category of ability hotbar and pickups. Already has ability check, we can do the same thing. Find empty hotbar slot, same thing. And pick up ability on hotbar, same thing. And then we have 2 acquisition functions, and might as well give that a category of acquisition. My Ferengi friends would be greatly appreciative. Identify inert potential acquisitions, compile and save this. Close out of this one. Finally, on to third person character here. Back to our event graph. So we'll zoom out, and all this temporary stuff that we've accumulated over the course of the last 3 episodes. Delete out all of this, except I'm going to keep V. But the rest of it, gone. Delete. V, I'm going to move up here. Compile and save this. And I'm going to close out of all of this. We'll do one final test. You know, it's rare that us creative types have the discipline to keep organized, so if you enjoy cleaning stuff up, kudos to you, man. It's only going to serve you well in the long run, and I mean that in regard to everything you do in your life. His aim seems to be on par with mine, if not better. And I'm sure we're only going to make this better with time, guys. So that concludes our episode for today. And you know, guys, we are just getting started with this series. We got fire effects coming up. We also got to make it possible for our AI to actually use our jump and speed boost and jump down into this hole right here. We got death and respawning to take care of. And truth be told, we're just getting started on gameplay abilities.